Hello, good afternoon, my dear students. Welcome to one more amazing session from Infinity Lane. This is Suresh, Faculty of Chemistry. In this one short questions, we are going to discuss about Arenes from the NEET examination. We'll discuss about the concept and followed by some questions based on that. So, how you all doing? Welcome to the session. Please confirm, can you all able to hear me, can see me? And today's class is all about Arenes, and in this NEET 2025 preparation journey, we started NEET launch program, then we are studying about NEET NCERT line by line. We had marathon sessions based on that, and every topic had been discussed. Later on, most expected questions we did it, and now we are in the kind of revision where we are talking about every topic like structure of atom, basic concepts of chemistry and general organic chemistry, hydrocarbons, okay, and haloalkanes and haloarenes, and we discussed about the chemical equilibrium, ionic equilibrium, thermodynamics, whatnot, everything. Hi, Ved. Yes, organic is always my favorite topic, Ved. Yes, of course. So, without delay, let us start the class. And before going for the session, we just always request you, just take a vote, crack your NEET examination. Hi, Ved, how are you? And please like our session, share with your friends, subscribe to Infinity Lane NEET YouTube channel. And Ved, you subscribed or not? I think you subscribed. Okay, and you just click the bell button and you will be getting all updates based on this NEET examination and NEET examination preparation strategies, questions, concepts, why not? And any updates related to NTA NEET will be discussed in this channel. Get ready, Gudia Sharma. Yes. And in the NEET, in the Google App Store, you can see Infinity Lane app. You can download this app and you can see live classes, mock test, create your own test, and many more, and for free of cost, everybody. बहुत पहले से content है. Okay, now I am going to give you the best. For today. Lakshmi Busa, All India Test Series for NEET 2025. It is completely for zero cost, and you can just click and access it. Okay, hi. And it cost is of 5,999. It is given for free of cost. Infinity Lane want to do the best for the students. So for that, at the last, for any student, and not even single student miss this, for that limited time offer, get your 100% discount. You just simply click the link is available in the chat box and the description box, and you can apply AITS 100 free. This coupon code can give you, this is for free of cost. And enroll now. You can access 29 All India Test Series. उसमें आपका 15 यूनिट टेस्ट है, 4 पार्ट टेस्ट and 10 ग्रांड टेस्ट and 20 online NEET full syllabus test, and for every test video solutions are there, and it is for the students. Infinity Lane want to do the best, and it is the best. इससे best आप क्या कर सकते हैं, है ना? Hi, Sheikh Tahera, the confirm yes, it is true, free of cost. It is completely free. Yeah. So far we discussed this for 50% off, 60% off, 40% off, 60, 80% off था कल तक. आज से 100% free है. Believe it or not, you just click it, you'll understand. Okay, why? Okay, so without any delay, let us start the class. Okay, Arenes, aromatic compounds. So you're going to learn about what you learn in this session. This session is of 2-hour session. We'll discuss the best out of it. We'll talk about the aromaticity, introduction to the structure of benzene and the preparation of benzene, electrophilic aromatic substitution of benzene, and last but not least, it is going to be direct to influence of mono-substituted benzene. So this is the content that will be discussed in today's class. अगर आप कुछ डाउट मिले तो बीच में आप चार्ट में आप पूछ सकते हैं. Okay, and definitely from this particular Arenes chapter में आपका कम से कम 2 क्वेश्चंस आने का संभावना है बेटा. कम से कम 2 क्वेश्चंस का 8 मार्क्स आपका पॉकेट में है. Okay. Is my voice is audible? All students, I think you just confirm, is my voice is audible? Yeah, my mic is working, it is close to me. My mic is working, is close to me. You just check your side, from your side. Let me check. Yes, it is. Okay, my dear students, let's talk about aromaticity. Now, let's talk about the reactions of alkenes. When you talk about alkene, when you discuss, add with cold alkaline KMNO4, पहले add करने का पहले ये pink था, the pink color of this is going to be decolorized and pink is color becomes colorless. Why KMNO4 is going to react with an alkene? है ना? Now it is fine. Now, so the same thing can happen with alkyne as well. Both alkene and alkyne is going to react with KMNO4. You want to make it reaction with alkyne is also the same. Addition of Bayer's reagent to benzene. So क्या बात है? So add KMNO4 to the benzene. In the alkaline medium, so there is no reaction at all. There is no reaction. ताकि इसका पिंक कलर डिस्चार्ज नहीं हो रहा है, क्योंकि बिकॉज ऑफ कॉन्सेप्ट कॉल्ड एरोमेटिसिटी की वजह से. What is aromaticity? The resonating structures of benzene, if you want to say, it has its resonating structure like this. Because of the resonating structures, जो ये pi bond है ना, ये KMNO4 के साथ react करने का available नहीं है. So अगर नहीं react हो तो क्या होगा? In this reaction, in this ring, the electrons continuously revolve in a circular path, that there is a sustained continuous current in the ring. Again, now, if the direction of the ring current is diatropic and polytropic, paratropic, you can say that. So, based on this classification of the cyclic organic compounds are given in 2-3 types: aromatic, anti-aromatic, and non-aromatic. So, what is the criteria to say a compound to be aromatic? What is the criteria to say it is an anti-aromatic? What is the criteria to say it is a non-aromatic? ध्यान से सुनो बच्चों, everything I want to give you conditions for aromatic compounds. ये aromatic compounds condition जो है ना, there has to be a ring. Ring must be planar and no atom in the ring must be sp3. So complete cyclic system should be there. And it must be fully cyclic conjugated. का मतलब क्या? So within the ring, resonance should be complete in the cyclic system. And it must follow Hückel rules, that there must be having 4n+2 number of pi electron system. Okay. So if these 4 points, point number 1 and point number 2 and point number 3, if these are accepted, then only you can say the compound is aromatic. समझ में आ रहे क्या बेटा? Sheikh Tiwari, Ved and Lakshmi, everybody, Gudiya Sharma, Ved, come on, just give a thumbs up and fire emoji to confirm that you all can able to hear me and see me. Wonderful. Now आगे बढ़ते हैं. Example, if n is equal to 0, then we will get the following: 4n+2 pi electrons is going to be 0, just 2 electrons are there, just like you say it is a cyclopropenium carbocation is the example for this. And similarly, if n is equal to 1, n is equal to 2, n, you have to say 4n plus 2 is equal to number of pi electrons, count करके यहाँ पे डालो, solve for n. So if n is equal to any integer including 0, then it is said to be it is aromatic. Then it is said to be it is aromatic. Understand? Clear beta? That is the simplest thing. And similarly, you can say benzene. It has for n+2, you have 2 electrons over here, 2 electrons over here, 2 electrons over 3 pi bonds are there, so that 6 electrons are there. On solving, n is equal to 1, ताकि इसका aromatic बोलना. It should be aromatic. Are you getting or not? Clear? Fine. Okay. Now let's see here. Note, if more than two p orbitals are parallel and overlap simultaneously, then there is a conjugation given one of them is filled and the other is vacant. And also characteristics of aromatic compound. They have a characteristic smell. Yes, of course, they have a characteristic smell. When you see coffee, okay, you have a coffee aromatic, some smell, characteristic smell. Rose, they have extra stable. Aromatic compounds have extra stability, and they burn with sooty flame. They burn with a lot black smoke color, black color smoke flame they burn. So these are the observable things we can say, है ना? And also classification of compounds, again I said aromatic, anti-aromatic and non-aromatic. So अगर aromatic compound आप देखना चाहता हूँ, ये aromatic compound benzenoid and non-benzenoid होगा. So benzenoid benzene का जैसे दिखता है, non-benzenoid उसमें benzene ring नहीं होगा. So these are all non-benzenoid aromatic compounds. So let's talk about the benzenoid aromatic system. So the molecules have the benzene ring is known as an aromatic benzenoid compound systems. So students here, look at here. It's an example. Naphthalene is an example. Anthracene is an example. Phenanthrene is an example where number of pi bonds are 5. So 1, 2, 3, 4, 5. Number of pi bonds are 7. 1, 2, 3, 4, 5, 6, 7. Similarly, phenanthrene also have number of pi bonds are 7. So number of pi electrons इसके double होना चाहिए. So 5 become 10, 7 become 14. Right? So you can apply 4n plus 2 for everybody. So want to say 4n plus 2 is equal to 10. N is equal to 2 aromatic. 4n plus 2 is equal to 14. N is equal to 3. 4n plus 2 is equal to 14. N is equal to 3. है ना? Yes. So what are anti-aromatic compound? So before going for this anti-aromatic and aromatic and non-aromatic, you have. So you have the characteristics of the aromatic system. You can see, yes, these are the characteristics. First point, second point, third point, fourth point. Okay. So I want to say here, dear children, aromatic compound and non-aromatic compound and anti-aromatic compound. So when you talk about this aromatic and non-aromatic and anti-aromatic compounds, so carefully you see, aromatic compound first point is accepted, second point is accepted, and third point is accepted, and fourth point is also accepted. I want to say first point, second point, third point, and fourth point. These 4 points are accepted. That is called as aromatic compounds. Okay. Now let's talk about the non-aromatic compound. First may be okay, and maybe your second or third is any one of these first 3 points is missing. So there is no way of checking with the fourth point. Such compounds are said to be non-aromatic compounds. It's a simple trick. And also you can say here, dear children, if first point is okay, second point, third point, and unfortunately fourth point is not accepting, that is said to be anti-aromatic compound. So these are the basic criteria to say, it is a trick to say the compound to be aromatic, non-aromatic and anti-aromatic. So these are the 3 different points we can say. Now when you talk about the stability, aromatic compounds are super stable, non-aromatic compounds and anti-aromatic compounds. Anti-aromatic compounds are super unstable. These are super unstable, and aromatic compounds are super stable. Everybody just click it, take a snapshot. Welcome, welcome, welcome again. So, moving ahead, बच्चों. So, all taken this. Sir, कम से कम बात करना यार. So, coming to the anti-aromatic compounds, benzenoid aromatic compounds and anti-aromatic compounds, these are super unstable compounds. है ना? And conditions for anti-aromatic compounds, they must be cyclic and planar, and they must be planar absence of sp3, yes, of course. And also they must be fully cyclic conjugated. Everything is there, but one thing is missing. There must be just 4n pi electrons. I mean to say 4n plus 2 is not actually following. 4n plus 2 is equal number of pi electrons. That's the empirical relation given by Hückel is not followed. And 4 pi electron, this is an anti-aromatic compounds. Clear? Any doubts? Sheikh Tiwari? Yes, now. Lakshmi, Gudiya Sharma, Ved. Yes, I want this session to be not like a radio session. I want this session to be like you see a live interactive session, so that you chill up and gear up and enjoy the session along with us, so that you can say this. Now, when you talk about the cyclobutadiene, this cyclobutadiene has 4n plus 2 is equal to 2 pi bonds, means 4 electrons, n is equal to 1 by 2. If it is not a whole number, it should be anti-aromatic. So, I want to give you a simple trick, or I want to say small suggestion. When you are writing a mechanism, you are writing a chemical reaction in the organic chemistry, अगर आप product में जो compound form कर रहे हैं ना, अगर ये compound anti-aromatic मान के चलो, ये reaction आगे नहीं बढ़ता. अगर जो product है ये aromatic होगा तो reaction आगे बढ़ सकते हैं, and the product is going to be हमेशा super stable होगा. Aromatic super stable, anti-aromatic बिल्कुल stable नहीं होगा, जैसे compounds form करते हैं नहीं. Understand? Now talking about non-aromatic compound, as you know, these are all the examples of the non-aromatic, जिसमें जो cyclic system एब्सेंट है, इसमें साइक्लिक सिस्टम है, लेकिन ये यहाँ पर जो रेजोनेंस भी नहीं चल रहा है, सो जैसे कंपाउंड्स नॉन एरोमेटिक बोलना. सो ऑर्डर ऑफ स्टेबिलिटी बच्चों, एरोमेटिक आर मोर स्टेबल देन नॉन एरोमेटिक, आर मोर स्टेबल देन एंटी एरोमेटिक कंपाउंड्स. समझे? एंड आल्सो बेस्ड ऑन द एरोमेटिसिटी, व्हिच ऑफ द फॉलोइंग इज एन एरोमेटिक. सो क्वेश्चंस विल बी गिवन लाइक दैट. Questions will be given like that. So it is just we calculated, this is for. Now when you talk about this is an example, you have 4n plus 2 is equal to 4 electrons, n is equal to 1 by 2, it is anti-aromatic. It is cyclic conjugated system. So that 4n plus 2 is equal to 1, 2, 3, 4, 5. 10 electrons, n is equal to 2. It is of course aromatic. It is aromatic. ठीक है? And when you just see here पर resonance is not there. Resonance is not there. So it is said to be non-aromatic. So जिसमें sp3 कार्बन बीच में घुसा हुआ, ये भी नॉन एरोमेटिक होगा. सो दैट इज द verbal explanation that I have given you. So everybody just see and understand what you know about this. अगर कुछ डाउट है ना तो आप बीच में आप क्वेश्चन पूछ सकते हैं चार्ट बॉक्स में. फाइन. नाउ लेट अस टॉक अबाउट द ऑप्शन इज बी इज द करेक्ट आंसर. राइट, इट इज एन एरोमेटिक. सो नीट में जैसे क्वेश्चंस आपका आने का संभावना है बेटा बेस्ड ऑन एरोमेटिक्स. व्हाट इज द ऑर्डर ऑफ स्टेबिलिटी? फिर भी एक क्वेश्चन है. आई वांट टू सी द आंसर इन द चैट बॉक्स फ्रॉम यू ऑल गाइस. आई वांट टू सी द आंसर. आई वांट टू सी. ऑफ कोर्स इट इज एरोमेटिक and it is a non anti-aromatic. And it is a non-aromatic. आपका जो स्टेबिलिटी ऑर्डर क्या? स्टेबिलिटी मीना, आपका स्टेबिलिटी ऑर्डर क्या? मीना आपका बोलो. एरोमेटिक is more stable than non-aromatic, is more stable than anti-aromatic. Okay. Now if you see, the answer is going to be aromatic, non-aromatic and anti-aromatic. समझे? ACD, that's good, that's good. And सारा questions है, आगे आप कर सकते. And based on the aromatics and aromatic compounds, why do aromatic compounds burn with a sooty flame? They burn with a sooty flame. Relatively, they have the high percentage of carbon. It's, everybody knows they burn with a sooty flame. Why so is explained based on this. Fine. And also, this is a super important quasi-aromatic compound. And aromatic compounds which are positive or negative charges are said to be part of a Hückel rule, and they're said to be quasi-aromatic compounds. Like an example, you can see trophylium cation is a quasi-aromatic. cyclopentadienyl anion is quasi-aromatic. एक ऐसा हो सकता है. Now you see cyclopentadienyl. Let me go and use this another slide. Yeah. Here you can see. दिखाई दे रहा है ना? So this is actually a neutral molecule. When you go with this, okay, and it is going to be like one hydrogen is lost as H plus, it is going to form a cation like this, anion like this. This is aromatic. When you talk about a trophylium cation, you can see this is trophylium, tropolone. When it is polarized, my dear students, you are going to see like this. Now this is aromatic and this is aromatic. So neutral species become charged so that it is going to get aromatic nature. Such compounds are said to be aromatic. Okay, मीना पूरन मीना ओके अगर जो न्यूट्रल मॉलिक्यूल है ना थोड़ा सा इंटरनल मॉडिफिकेशन करके पाई बॉन्ड शिफ्ट करने के बाद इसका पोलराइजेशन मिल गया. ओके मीना नाउ दिस इज व्हाट यू से ट्रोफाइलियम जैसे देख रहे हैं ना. सो दैट इफ यू कैन से 4n plus 2 is equal to कितना इलेक्ट्रॉन्स डीलोकलाइज कर रहे 1 2 and 3. So 3 pi bond मीना and 3 pi bond means you are going to say 6 electrons. So n सॉल्व करने के बाद आपका होगा 1. So ताकि इसका एरोमेटिक बन जाएगा, एरोमेटिक बन जाएगा. ठीक है. Now is also very good important thing, and the lone pair of electron participating in resonance, here it is equal to be n is equal to 1. And you have another one, cyclopropenyl cation. Cyclopropenyl cation ये भी है like this. 4n plus 2 is equal to 2 electron, n is equal to 0. So ये भी aromatic होगा. So characteristics of quasi-aromatic compound है, they are highly stable, of course ये stable होगा, and they are soluble in polar solvent क्योंकि ये charge का वजह से ये soluble हो सकता है. ठीक है बेटा. And they have high dipole moment. Yes, polar, they are polar, so dipole moment भी ज़्यादा से ज़्यादा होगा बेटा. And they have high boiling and melting point. जैसे आपका चार्ज हो इसका इंटरमॉलिकुलर फोर्सेस भी ज़्यादा होगा, सो दैट इसका बॉइलिंग पॉइंट भी बढ़ जाता, मेल्टिंग पॉइंट भी बढ़ जाता. क्वाशी एरोमेटिक हैज़ दिस 4 डिफरेंट स्पेशल प्रॉपर्टीज. समझ में आ रही है कि बेटा? क्लियर मीना? फाइन. जस्ट मेक ए क्विक नोट ऑफ इट, जल्दी से जल्दी. हाँ यस, आगे बढ़ेगा, थोड़ा आगे बढ़ता. And based on the stability of molecule, out of these two compound which is more stable, this is benzyl cation. benzyl cation stable है रेजोनेंस के वजह से, ट्रोफाइलियम cation भी स्टेबल है रेजोनेंस के वजह से, लेकिन ये एरोमेटिक भी है. एरोमेटिक सिस्टम जैसे हमेशा ज़्यादा से ज़्यादा स्टेबल होगा बेटा. B. सुनील, हाय सनील लालवी, वंडरफुल. एंटी एरोमेटिक में एक्सेप्शन कौन सा है? Just a minute. Don't remember the name. Really? Don't worry, मैं हूँ ना, मैं एक्सेप्शन देना चाहता हूँ, कोई प्रॉब्लम नहीं बेटा. जस्ट ए मिनट, मैं आपको देना चाहता हूँ, कोई प्रॉब्लम नहीं, 1 मिनट। Yeah. Now, based on the stability out of two compounds, the cyclopentadienyl anion and a benzyl anion. Cyclopentadienyl anion is aromatic, so it is going to be more stable. Sanil Dalvi, you came late. 8-member chain hai, that I am going to tell you. That is bathtub cyclooctatetraene. That is cyclooctatetraene. Okay, don't worry. Okay, so before going for that, Sanil is asking one question. So you guys say, is it aromatic or non-aromatic or anti-aromatic? Let me draw this instantaneous drawing. Cyclooctatetraene. So people claim this is, Sanil, people claim this is anti-aromatic. People claim this is an anti-aromatic. No, it is not aromatic. It is going to be non-aromatic क्योंकि इसका जो स्ट्रक्चर है ना ऐसे दिखता है. It is non-planar. It is non-planar ताकि इसका बोलना चाहता हूँ it is non-aromatic. ठीक है? Sanil, happy? Enjoyed it? Happy? Enjoyed it? Now we are going to exactly. Now let's see the structure of benzene, bachcho. Structure of benzene and preparation of benzene and the structure of benzene. You have to prepare from it. Okay, first let us talk about the preparation of benzene. Then we go with the structure of benzene. Then go with the aromaticity of benzene. Then you go with the electrophilic aromatic substitution reactions of benzene. Then we start with the substitution reactions of mono substituted benzene. इसका जो activation आ सकता है, deactivation आ सकता है. So that is the overall flow I want to maintain here, dear students. So you can prepare it from alkanes. So it is your N-hexane. In this N-hexane, 6 carbon atoms are there. Okay, this can also be written like this. It is your N-hexane 1, 2, 3, 4, 1, 2, 3, 4, 5 and 6. And it is treated with Cr2O3, L2O3 at 600 degrees centigrade. Dehydrogenation, cyclization followed by aromatization takes place. This is what is called as aromatization. अगर मान के चलो आपका पास N-heptane भी होगा ऐसे, this is 1, 2, 3, 4, 5, 6, 7. This is N-heptane. And this is N-heptane. When you do so, Al2O3 and Cr2O3 and you heat it. So what is going to happen? You all tell me what is going to happen. The product always maintain the 6-membered ring is going to be super stable, so that you're going to see the formation of benzene again. लेकिन compound एक कार्बन ज़्यादा होगा So you're going to see toluene as the product. N-heptane gives rise toluene and N-hexane gives rise आपका benzene. Understand, this is a very popular reaction that you see in the petrochemical industries as well. And also preparation of benzene for cyclic polymerization of acetylene. When acetylene gas is passed through red hot iron tube, so it is going to be cyclic polymerized and it is going to give benzene as a product. Understand? Cyclic polymerization. Cyclic polymerization. Now I want to ask you a question. What will happen? Propane undergo cyclic polymerization. What would happen if propane undergoes cyclic polymerization? CH3, C triple bond CH and cyclic polymerization. What is the product? Quick. So going to see NEET examination में आपका ऐसे questions आपका पूछा जाएगा. So it is going to be CH3 and it is going to be CH3, it is going to be CH3. Understand? Clear? Now, preparation of benzene from phenolic compounds by deoxygenation. You can say it is a reduction. It is a reduction. Deoxygenation or reduction. When phenol is reduced by zinc metal, so zinc is going to take this as a zinc oxide to form the benzene. Similarly, it is a cresol, okay, it is a xylene. Xylene is going to take out orthoxylene, so it is going to get a toluene, okay. Xylene gives rise to toluene. And also you can see from carboxylic acids by decarboxylation. So the benzene carboxylic acid or benzoic acid is heated with soda lime. What is soda lime? Sodium hydroxide and the calcium oxide, and it is going to remove carbon dioxide. So removal of carboxylic group is carbon dioxide is called as a decarboxylation. Sanil Dalvi, you're going to get a benzene and this is can you say the name of the compound, Bacho? Can you say the name of the compound here? This is what is called tolic acid, okay, and it is removed and it is a soda lime. Sodium hydroxide and calcium oxide is soda lime, gives rise or toluene. Understand? And let us see preparation of benzene by Grignard reagent. Phenyl magnesium chloride is treated with water and it is going to give rise to benzene. How do you get phenyl magnesium chloride? So the chlorobenzene is treated with magnesium in dry ether. Magnesium in dry ether, you are going to see the formation of phenyl magnesium chloride, and this is your Grignard reagent, which is a strong base and an excellent nucleophile. So that if you add something like water means Hu plus and OH minus, so that MgClOH is formed. MgCl and OH is formed and it is going to get the benzene over here. That is the reaction. Okay, clear? Any doubt बच्चों? Next, preparation of benzene from benzene sulfonic acid, and benzene sulfonic acid is hydrolyzed to give rise benzene and H2SO4. So sulfonation of benzene reaction, we can say this is benzene sulfonic acid is reversibly going back to the benzene, and we'll discuss that reaction also, students. And preparation of benzene from benzene diazonium chloride, it is popularly known as BDC. When BDC is subjected for this is aniline. When aniline is treated with NaNO2HCl at low temperature like 0 degree centigrade to 5 degree centigrade, you are going to get benzene diazonium chloride, BDC, and it is on treatment with He3PO2, or you can also use C2H5OH. You are going to get benzene. And if I add BDC to water, what will happen? Water is added. What is the product? Somebody tell me what is the product you are going to get it. Somebody in the live class, you please tell me what is the product you can get when benzene diazonium chloride is hydrolyzed. Surprisingly, it is going to give you toluene. You are going to get a phenol. ठीक है? Now let's see the properties of benzene and the structure of benzene, बच्चों. Structure of benzene. Yes, it is. Now benzene, the preparation reactions of benzene. So the reactions of benzene is based on its aromaticity. When you talk about, you just see, when you see here, this is your cyclohexene. When you treat with Br2CCl4, you are going to see the formation of addition reaction. It is an electrophilic addition reaction. It's very important. It is, what kind of reaction is this? It is an electrophilic addition reaction. Now let me take a benzene. And add Br2 and CCl4. There is no reaction. So when there is no reaction, I am forced to claim benzene do not undergo electrophilic addition reaction. Why it do not undergo electrophilic addition reaction? Because of this is in resonance due to delocalization of pi electron ring. Due to delocalization of pi electron system and aromaticity. Assertion and reasoning, NEET एग्जामिनेशन में जैसे क्वेश्चंस एंड स्टेटमेंट्स काफ़ी इम्पॉर्टेंट है. ये पॉइंट्स पकड़ के आप मार्क लूटने का कोशिश करो बेटा. दैट्स द रीज़न वाई बेंजीन का अलग तरीका रिएक्शंस आ सकते हैं. सो बेंजीन इज गोइंग टू रिएक्ट विथ Br2 and FeBr3 Okay, FeBr3, we are going to get bromobenzene. ये क्या reaction है? So this is electrophilic aromatic substitution reaction. Electrophilic aromatic substitution reaction. समझ में आ रही है? This is the actual clear picture you need to know. दो बेंजीन का पास 3 double bonds है. Though benzene has 3 double bonds in it, do not behave like an alkene. The reason है कि this is the reason due to delocalization of pi electron system and aromatic in nature. समझे? अगर डाउट है ना तो फटाफट चार्ट बॉक्स में आप दे सकते हैं जल्दी 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 दे सकते हैं. Next, this is the structure of benzene. Okay, let's go into the electrophilic aromatic substitution reactions of benzene. Get ready, you are all going to get the question here itself, electrophilic aromatic substitution reactions of benzene. So most important reactions of benzene are electrophilic substitution reaction. They are also denoted by SE reactions. Okay, bacho, come on, focus here. And I want to say here, when this is your benzene and benzene has a hydrogen over here, that hydrogen is replaced by an electrophile. So H2 plus come out and electrophile is being replaced. So this is a replacing reaction or substitution reaction, and this is done by an electrophile. So it is called as electrophilic aromatic substitution reaction. And you can see the mechanism. First, मान के चलो, this is the pi electron system. It is attacked by the electrophile, so that you are going to get a sigma complex, and this sigma complex is going to taken away by the counter nucleophile to give its the substituted benzene. Now this is a pi bond is forming a new sigma bond, है ना, and it is resonance stabilized, and this is what is called as a sigma complex. This is what is called as sigma complex. समझे? Clear? And also you can say the 5 most common electrophilic substitution reactions, the 5 most, not 5 most golden reactions of benzene. Golden reactions of benzene. What are these golden reactions of benzene? Halogenation, or a bromine or a chlorine or iodine substitute for the hydrogen is called as halogenation, and nitration, a nitro group substitutes on hydrogen, and sulfonation, sulfonic acid group is substituted for hydrogen, and also Friedel-Crafts acylation, and you have the Friedel-Crafts alkylation. These are the 5 major reactions that we see as far as the reactions of benzene are concerned. Okay, and let us talk about the bromination. So in this bromination, bromine is reacted with benzene in the presence of FeBr3, gives rise to bromobenzene. This reaction is called as a bromination. Okay, so what exactly happened? Bromine react with FeBr3, so that what happens? Br2, so Br and Br, so bromine को bromine के बीच में ये एक bond है ना, so FeBr3 it is a Lewis acid. This is also called as a halogen carrier, or you can say it is a Lewis acid. So what happened? This electron pair is going to be donated. Lewis acid क्या करते हैं? Electron donate करते हैं, ले सकते हैं, so that it is going to give you Br plus and FeBr4 minus बन गया. So this is an electrophile. Let's see the chlorination. ये भी ऐसे है. When chlorine is treated with benzene in the presence of FeCl3 to get this chlorobenzene. Understand, बच्चों? That's pretty good. And iodination. So when benzene is treated with iodine and HNO3, it is going to give us iodobenzene. Reaction हमेशा electrophilic. This is reversible होता. Okay. For that we need to go with the iodobenzene preparation by benzene diazonium chloride. Okay. And let's see, in iodination oxidizing agents like HNO3 इस्तेमाल कर सकते हैं आप, HiO3 भी इस्तेमाल कर सकते हैं to oxidize HI in reducing agent. Okay. In presence of sunlight and absence of halogen carriers like AlCl3, FeBr3, BCl3 भी इस्तेमाल कर सकते हैं. They are acting as a Lewis acids. They are acting as a Lewis acids. Okay. And benzene adds 3 molecules of chlorine to form benzene hexachloride. That's a different matter. That is called gammaxane. That is an antikiller. That is an antikiller. We use this antikiller at house. Okay. So this is very, very important. Okay. You have to use sunlight for this. समझ में आ रही क्या? Make a note of it. Everybody clear? Make it fast. Make it fast. Any doubt? बच्चों, present in the chat box. Present in the chat box. Yes. And it is an addition reaction, not a substitution reaction. That's very important. And nitration. So what exactly happened? The reaction, benzene is treated with HNO3 in the presence of H2SO4. You're going to get nitrobenzene. So HNO3 and H2SO4. This is what is called as a nitration mixture. It is what is called as a nitration mixture. So actually what happened, this nitric acid, the lone pair of electron is given to the sulfur, sulfuric acid. So of course HNO3 concentrated is a strong acid, but it is donating a lone pair of electrons, so that is called Lewis base. Can you believe it? Now OH become a poor leaving group, now it is a better leaving group. So the entire part is a good leaving group is lost as water molecule. You are going to get a nitronium ion. You can say it is a NO2 plus nitronium ion which act as an electrophile. है ना? Nitronium ion act as an electrophile. That is going to be acted, and sulfonation. In the sulfonation, sulfur triple bond is there. Sulfur 3 oxygens with multiple bond is there. Because of the electronegativity of the sulfur, itself act as an electrophile. So what happened when this H2SO4, concentrated H2SO4, you have to use concentrated H2SO4 and sulfur trioxide mixture, you can say it is a fuming sulfuric acid. It is called as a fuming sulfuric acid. This fuming sulfuric acid is going to react with benzene to give rise benzene sulfonic acid. Mind it, so far the reactions what you studied is always forward reaction. This is only the reversible reaction, and this is what is called as benzene sulfonic acid. And talking about sulfonation of benzene is a reversible reaction. If the benzene sulfonic acid is heated to dilute acids, and the reaction proceeds in the reverse direction, mind it, the reaction goes in the reverse direction. Okay, wonderful. And so many questions are waiting for you. If you are ready to do, we'll do it. Questions आइए. Before going for this, and it's a long session, I would say we'll go for a 3-4 minutes break. Is that fine, my dear students? Let's have a 4-5 minutes break so that we'll start again, right? Okay, we'll see you. Stay tuned, my dear children. Now we are back. We are back. Thank you very much. So it's a long marathon sessions where we need to have a short breaks. Okay, all ready for set, go. So sulfonation is a reversible process. If benzene sulfonic acid is heated with dilute acid, then the reaction proceeds in the reverse direction as well. And also you can say introduction of alkyl or acyl groups in the presence of catalyst which require alkyl group के लिए Friedel-Crafts इस्तेमाल करना. Friedel-Crafts acylation, alkylation. You have to take. Hi Suresh, how are you? Suresh, how are you? Right. So you have to use catalysts like AlCl3, yeah, FeCl3, AlCl3, FeCl3, SbCl3 acting as a Lewis acid. The protonating agents like you can also say HF, H2SO4, H3PO4, these are known as Friedel-Crafts reactions. Okay, I'm fine. Okay, so आपका NEET एग्जामिनेशन का पढ़ाई कैसे चल रहा है बेटा? शेख तेहरा and Suresh Kumar, Poonam Meena and Sunil Dalvi, Ved and all students who are online, please interact with us and let us discuss about the alkylation. When benzene reacted with alkyl halide in the presence of AlCl3 are going to get an alkyl benzene. And benzene react with methyl chloride is in the presence of AlCl3 gives us methyl benzene is called as a toluene. So where you can see when alkyl chloride is reacting with AlCl3, I want to write a little bit over here. So alkyl chloride is treated with AlCl3. So aluminium chloride is having a vacant orbital. Therefore इसका जो lone pair of electrons है ना इसका दे देता है, इसका Lewis acid होगा and this is a Lewis base होगा. So there is a Lewis acid base reaction बनेगा. So that what happened? There is a formation of the bond here, breaking of a bond. As a result of this, alkyl carbocation is formed, the AlCl4 minus is formed. समझे? And alkyl carbocation जैसा form है ना, this is called electrophile. This is called electrophile, right? And note the above reaction can be achieved with an alcohol with HF, an alkene with HF and dilute H2SO4. Like you can see this R O H in the presence of HF, HF मान के चलो आपका H plus and F minus होगा ना. So this H plus is going to be protonated over here. So this is a poor leaving group. Once it is a protonated, it is a better leaving group ROH2 plus बनेगा, and this is going to be like this, and a carbocation is formed. Carbocation is formed and water molecule is eliminated. You understand? Clear? Now acylation. When benzene is treated with acyl chloride, you are going to give it a acylated benzene. So this is called as a Friedel-Crafts acylation. So here acylinium is an electrophile over here, and Friedel-Crafts acylation better it is followed. And when you talk about this, acylation can happen from acyl chloride is treated with AlCl3, get again acylinium ion. This is one method. And acetic anhydride, any anhydride, when you take an halogen carrier and you are going to see the bond is broken, you are going to get acylinium ion. है ना बेटा? That's good. And when benzene is treated with acylinium ion, you are going to get acylated benzene. And this acylinium ion is resonance stabilized, and it is going to be the intermediate. Sheikh Tiwari, ha sir. एंड ये दोनों स्ट्रक्चर में शेख तिवारी आप बोल सकते हैं कौन सा स्टेबल है, स्ट्रक्चर 1 और स्ट्रक्चर 2, ये दोनों में कौन सा स्टेबल है बेटा, ये दोनों में कौन सा स्टेबल है, स्ट्रक्चर 1 एंड स्ट्रक्चर 2 स्टेबिलिटी, ये दोनों में कौन सा स्टेबल है बेटा, स्ट्रक्चर 1 एंड स्ट्रक्चर 2. रेजोनेंस स्टेबिलिटीज स्ट्रक्चर 2 ही इज मोर स्टेबल देन स्ट्रक्चर 1 मान के चलो. बाय बिकॉज दिस इज कार्बन 6 इलेक्ट्रॉन्स का है, इट इज कार्बन 8 इलेक्ट्रॉन्स के. जैसे रेजोनेटिंग स्ट्रक्चर ऑक्टेट बराबर है, जैसे स्ट्रक्चर ज्यादा स्टेबल होगा बेटा. दैट्स वेरी गुड, दैट्स वेरी गुड. नाउ aryl and vinyl halides cannot use in the Friedel-Crafts reaction. They do not form carbocation easily. That's an interesting thing. That's an interesting thing. Now, when benzene reacted with vinyl chloride in the presence of AlCl3, reaction आगे ना बैठता, so there is no reaction बच्चा. And these are the trap actually एग्जामिनेशन में आपके पकड़ने के लिए ऐसे क्वेश्चंस पूछा जाएगा. नीट एग्जामिनेशन में 100% मार्क्स लेने का कोशिश करो. आज से मैं नीट एग्जामिनेशन पेपर डिस्कस करने का रात नाइट टाइम आल्सो आई एम कमिंग एंड डिस्कसिंग द पेपर्स ऑनलाइन ऑन यूट्यूब. बच्चों टेक केयर, सेलेक्टिव पेपर्स भी पकड़ना है. एंड आल्सो in substituted benzenes like Friedel-Crafts reactions gives a poor yield when the electron withdrawing group, deactivation groups are present in this ring. जैसे आपका नाइट्रोबेंजीन होगा, जैसे आपका साइनोबेंजीन होगा, आपको बेंजीन कार्बोक्सिलिक एसिड होगा एंड एसाइल बेंजीन होगा and जैसे compounds NR3 भी है. अनुष्का रॉय, फर्स्ट ऑफ ऑल यू टेल मी हाउ आर यू. अनुष्का रॉय टेल मी हाउ आर यू. आजकल नहीं देख रहे चैट बॉक्स में, आप आ रहे नहीं आ रहे, और वाचिंग द रिकॉर्डिंग और नॉट एबल टू कम. And I really enjoy the classes with you guys. If you don't come now, I feel I miss something. Good sir, I was here only, but कम से कम हाई नहीं बोल रहा है. You want to see recorded version है ना? Okay, कोई प्रॉब्लम नहीं. एंड रिकॉर्डेड वर्जन जब देखते हैं ना, एक बार लाइक मारो. अरे कम से कम डाउट भी पूछ सकते हैं ना. रिकॉर्डिंग में जो कमेंट्स आते हैं नीचे, कमेंट में एक डाउट डालो. आई एम गोइंग टू टॉक discuss the doubt if you watch the recording and give a comment. है ना बेटा? Now, and जैसे compounds है ना, which of the following do not participate in Friedel-Crafts reaction? These are the compounds. In Friedel-Crafts alkylation, most stable carbocation form the halides can rearrangement. You can say when you can see this is the one. Okay, or you can see this is the one is going to give the weird product rearrange करने के बाद. पहले ये देखो, so CH3, CH2, CH2 and Cl in the presence of AlCl3, you're going to see a primary carbocation CH3 and CH, no, CH2 प्लस rearrange करने के बाद आपको मिलेगा CH3 एंड CH2. सेकेंडरी कार्बोकैटायन है ना, ये ज़्यादा स्टेबल होता, ये ज़्यादा स्टेबल होता. अंडरस्टैंड? सो दैट व्हेन इट इज अटैक्ड ऑन द बेंजीन, it is attacked on the benzene, okay, you are going to get CH and CH3 and CH3. ठीक है? Got it? Now let us see the second one. CH3, CH double bond CH2. when you use some kind of an acid like HF, okay, it is protonated, so it is going to get CH3, CH and CH3. Are you getting or not? When it is treated with benzene, and you are going to get this CH and CH3, and it is going to be CH3. Are you getting or not? Clear? Same. Wonderful. अनुष्का, अगर कुछ डाउट है ना? Yes. Now, in intramolecular Friedel-Crafts reaction, alpha and beta and gamma alkylonic acids and alkanoyl chlorides give cyclic products. This is a super important point. Okay, you can use this for the high-end questions in the NEET examination. So you never find this kind of super awesome tricks. So what is that? When you see here, it is 1, 2, 3, 4. 4-phenyl butanoic acid. When it is treated with HF, you are going to see this is going to attack here. Acylation takes place. So this is what is called alpha tetralone. Alpha tetralone, है ना? When it is going to be this, okay, so you are going to see this going to attack over here, so it is going to cause a compound like this. Understand? Understand, this is what is called as intramolecular Friedel-Crafts reaction. This is what is called within the molecule Friedel-Crafts reaction. Understand? A very good concept you learned in today's class. Very good concept. Now, GPYQ, A B tha. Arre, whatever there is, A and NEET may be tha. And I want to say Anushka Roy and Sheikh Tiwari, okay, Sheikh Tahera, and I want to say the overall colorful pictures. Direct to influence of mono-substituted benzene, ये काफ़ी important है. So when you say there is some groups like ortho and para directions and meta directions, जहाँ पर electron group, a group that is attached to the benzene is giving electron to the benzene, so it is called as electron releasing group. In that electron releasing group, you are going to get a benzene ring is activated. When the benzene ring is activated, you are going to get ortho and para positions as in a substituted positions. Whereas electron is withdrawn, a ring is deactivated, the product is going to be a meta director. How do I know whether it is an activated or deactivated? You can see this here. Whenever a group is there, this group has a lone pair of electron, तभी इसका इलेक्ट्रॉन इसको दे सकता है पॉजिटिव मेसोमेरिक इफेक्ट का हिसाब से. दिस इज रिंग एक्टिवेटेड इलेक्ट्रॉन रिलीजिंग ग्रुप. So they are ortho and para directors, strongly activating, moderately activating, weakly activating, and that is a weakly deactivating. That is a different matter. Sir, how do I know? नीट का एग्जाम सिटी कब आएगा? एक हफ्ते में आएगा आपका. इन ए वीक और 10 days you are going to get. Okay, बच्चों, all students who are there right now may be watching these recordings in offline also. Whenever you are having some kind of doubts, Infinity Learn is always one step away for you to give you the services. Directly you can ask a question from the YouTube channel. You can connect to the Infinity Learn doubt resolution app is there. There you can ask. Otherwise, You want to go to any nearby offline centers and you can connect to any faculty over there and you can discuss the doubt with that faculty, and Infinity Lane by Sri Chaitanya is delighted to help you. So nobody is going to ask you, you have to pay. So everything is absolutely free of cost. है ना? And you can go, if you don't have doubts now, you can go and visit the nearby centers. Sri Chaitanya and Infinity Land knowledge hubs are there, and there you can ask any subject matter expert or any person over there to get some worksheet and a question paper and assignment that can help you. Everything is full free of cost for education. We are all there for education. Yes, this is the best series and the service. Thank you. Where do you stay? Tahira, where do you stay? So I can tell you the nearby knowledge hub centers for the Infinity Lane. Okay, anyways, don't need not share your personal locations. Okay, this is a YouTube channel. Okay, that's up to you. If you are staying any nearby places, all over India, Infinity Lane knowledge hubs are there. We can go and connect with them. Okay? Sri Chaitanya College only. Oh, wonderful. Which campus? Now, my discussion is here. How it is strongly activating? That is the question. How it is moderately activating? How it is strongly activating? Wherever lone pairs are there, it is strong. Only lone pairs are there, it is strongly activating. Here also lone pairs are there, but cross conjugation is there. जहाँ पर क्रॉस कॉन्जुगेशन आता है ना, एक्टिवेशन इज डिक्रीज्ड, सो दैट इज कॉल्ड मॉडरेटली एक्टिवेटेड. समझ में आ रहा है क्या? हाँ. सो वीकली एक्टिवेटिंग जहाँ पर अल्काइल ग्रुप्स आते हैं ना, हाइपर कॉन्जुगेशन का वजह से, हाइपर कॉन्जुगेशन की वजह से. लोन पेयर डिस्ट्रीब्यूटेड बोथ साइड्स. अनुष्का, दैट्स अ गुड लॉजिक. वेयर एज वीकली डीएक्टिवेटिंग, ऑफ कोर्स नेगेटिव इंडक्टिव इफेक्ट की वजह से हैलोजन्स हमेशा स्ट्रांगली माइनस आई इफेक्ट एंड वीकली पॉजिटिव मीसोमेरिक इफेक्ट. स्ट्रांगली नेगेटिव इंडक्टिव इफेक्ट का वजह से डीएक्टिवेट करते हैं, लेकिन वीक पॉजिटिव मीसोमेरिक इफेक्ट की वजह से डायरेक्शन बदलते हैं. ओके सर, Suresh Kumar, and talking about meta directors, moderately deactivating, strongly deactivating. जहाँ पर ये ग्रुप है ना, and benzene is directly attached, X and Y is there. जैसे मान के चलो इलेक्ट्रोनेगेटिविटी ऑफ Y is greater than X, ताकि इसका इलेक्ट्रॉन पेयर इस तरफ आने का संभावना है. So this is what is called as a negative mesomeric effect or negative R effect. Understand? And these are the strong negative mesomeric effects का है, and moderately mesomeric effect का strong deactivating, moderately deactivating. They are always meta directors. Understand? They are always meta directors. Any doubt, बच्चों? Any doubt? Okay. All right. Now Classify each substituents and activating, deactivating. Now this is the lone pair of electron is giving to it. Okay, positive mesomeric effect, but it is having a strong minus I effect. Because of strong minus I effect, okay, very strong, you can say it is deactivating. Whenever halogens are there, you consider only negative inductive effect. Okay. Now nitro group is there, minus M or minus R group. Okay. And CF3 group, it is going to get a super negative inductive effect, deactivating. NH3 group, it is going to be super negative inductive effect. This is the deactivating effect. Okay. And activating, how it is activating, but it's because of positive hyperconjugation. HC stands for hyperconjugation, and positive inductive effect, it is going to be activating. And this is the lone pair of electron is having a positive mesomeric effect, a positive R effect, it is activating. And this is an ester functional group, and this ester functional group is having positive mesomeric effect, and it is going to be negative mesomeric effect, so that it is deactivating. You understand how it is, how you have to work, whether it is activating or deactivating. Anushka Roy, Suresh Kumar, yes, Shaikh Tiwari, ester, ester, okay, this is an ester dear, ester, this is an ester. ऑक्सीजन, जब एस्टर का जो ऑक्सीजन है ना, ये सीधा बेंजीन रिंग को लगा होता है, पॉजिटिव मेसोमेरिक इफेक्ट होगा. अगर जो भी एस्टर है, इफ इट इज गिवन लाइक दिस, दिस इज आल्सो एस्टर. ओके, एंड इफ दिस इज द केस, you can say negative mesomeric effect. C double bond carbonyl of ester is attached, that is negative mesomeric effect. Oxygen of ester is attached, that is positive mesomeric effect. Okay, that is of ester functional group. Ester functional group, understand? And let's see, so activating, अगर activating group है, मान के चलो ये activating है, इलेक्ट्रोफाइल ऐड करना है तो आपका इलेक्ट्रोफाइल आर्थो होगा, आपका इलेक्ट्रोफाइल पैरा में जाके काटना है. सो अगर डीएक्टिवेटिंग मान के चलो, अगर डीएक्टिवेटिंग होगा, डीएक्टिवेटिंग ग्रुप लगा है ना, इसका हिसाब से आने वाले का इलेक्ट्रोफाइल सिर्फ मेटा में आना है. सो दिस इज कॉल्ड आर्थो एंड पैरा डायरेक्टर. जहाँ पर आपका रिंग एक्टिवेशन है, it is going to be a meta isomer, going to say meta director, it is deactivating. Ester, yes, ester functional group. ऑर्थो एंड पैरा मेटा पोजिशंस में मुझे थोड़ा सा कंफ्यूजन है सर ऐसे क्वेश्चंस में. यस, नाउ यू गॉट क्लियर पिक्चर अबाउट ऑर्थो एंड पैरा डायरेक्टर्स एंड एवरीथिंग, राइट? That's good. Now you can say rate of a reaction of toluene is faster than benzene. Why? Because toluene methyl group जो है ना, it is going to be ring activating. So this is going to be faster ring activating. ठीक है? And it is going to be ortho and the para director. And the rate of reaction of nitrobenzene is less now. How it is less? Because it is deactivating, so the reaction rate is going to be less than this. Understand? Right? And rate of reaction of chlorobenzene is less than that of benzene because of minus I effect. And the chlorine dominates over plus M effect sometimes, hence it's deactivating, but exceptionally it is ortho and para director. That's the reason why, of course, it is deactivating, because of its having a strong minus I effect. But it has a less weakly okay, weak placement effect. So placement effect decides this direction, but it is strongly, so rate of reaction is less. And electrophilic attacks in the ring which is activated. Now in this case, look at this. This is ring A and ring B, and here amide group is there. If you want to add a nitration mixture, so you are adding NO2 plus. Now this NO2 plus can attack here, NO2 plus can attack here. But this is the lone pair of electron, bachcho. This is the lone pair of electron is going in this way. So that this ring is activated, okay, and this ring is deactivated. So this ring is deactivated. So ring activation इसका पैरा पोजीशन में, इसका ऑर्थो पोजीशन में नाइट्रो ग्रुप आने का संभावना है. इसका रिपल्शन का वजह से ये माइनर बन गएगा एंड इट इज गोइंग टू बी, इसमें रिपल्शन कम से कम होगा, so that it is going to be the major product. You understand, this kind of questions are very important for NEET examination, very very important. Now, so now we can see methyl group is there, nitro group is there when HNO3 is added. So to which direction the product should be given? So here it is a ring activator. So iske baad sunna, so that this is ring deactivated, don't listen to him. So when this is related to this, इसका वजह से इसका हिसाब से ये आर्थो हो सकते हैं, इसका हिसाब से ये पैरा भी हो सकता है. Now we can see the relative products of this nitration. Clear? Anushka? Now और एक चीज है, if two substituents direct at the same position of electrophile follows the common orientation, it is also at a meta position, it is also at a meta position, so both will follow the same. And if the two substituents direct at different positions, the electrophile follows the orientation of the activating group. After this some questions will do it, some questions. So like you see toluene, so that it is activating and it is deactivating, it is deactivating. It is deactivating. Don't listen to it, listen to it. So when you say this is the correct way and this is the correct way, and you can make it nitration over here, you can make it nitration, but here nitration repulsion ज़्यादा होता है, यहाँ पे हो सकता है and यहाँ पर हो सकता है. So you are going to get the different products like this. Understand? And if two substituents direct at different positions, electrophile follows the orientation of the activating group. That is very important. So say an example here. The same way methyl group, इसके बाद सुनना, okay, and it is going to give the products like this. Now when this happens, you know, so this is going to be having a positive mesomeric effect. The same kind of example. When you talk about this, is going to be negative mesomeric effect. So whenever a positive mesomeric effect is there, negative mesomeric effect is there, and you learn about this positive mesomeric effect, and the electrophilic substitution takes place according to the nitration. Okay, ये भी हो सकता and ये भी हो सकता. So just want to say it is the major, it is going to be the major. Why? Because here a bit of repulsion can be experienced, here repulsion कम से कम होगा. Understand? Clear? Fine. And we'll give some more questions based on this. Identify the correct order of reactivity of the electrophilic substitution of the following compounds. Yes, 1, 2, 3, 4. Answer? Expecting an answer from this question. Expecting an answer from this question. You want to say B? Okay, Anushka Rai, C again. Now let's see. This is deactivating. It is also deactivating. It is activating. And deactivating is super deactivating. अगर ये सुपर डीएक्टिवेटिंग करने तो कम से कम रिएक्टिविटी होना चाहिए. So for this question 4 is the least, 4 is the least, 3 is the least, and उसमें 2 is the most. Answer C is the correct answer for this question. Answer C is the correct. You said D, it is answer C is the correct. So you only given B, C and D. It is 2, it is 1, then 3, then 4. अगर doubt है ना तो आप पूछना अभी. And the correct order of reactivity towards the electrophilic substitution compounds benzene, nitrobenzene and aniline. What is aniline? I forgot what is aniline. No, it's a typing mistake. Okay, what is aniline? So here it is aniline. And it is a benzene, and it is a nitrobenzene. 1, 2, and it is 3. Of course, it is having a positive mesomeric effect, and it is going to have negative mesomeric effect. I would say 1 is more reactive than 2 is more reactive than 3. NEET एग्जामिनेशन में क्वेश्चन इतना ही स्टैंडर्ड में आ जाएगा आपको. अनुष्का रॉय, क्लियर? Yes. Next question. The strongest deactivating. The strongest deactivating. Who is the strongest deactivating? Of course, your answer is going to be D, correct? Yes, it is. And one more question. Which of the following is a maximum reactive for nitration? It's a very good question. It's a very good question. Focus here, focus here. You want to say D? How? Which of the following is a maximum reactive for nitration? D? Okay, let me check. Let me check the structures. The previous one. तो ये क्वेश्चन के लिए आंसर क्या होगा बेटा? ये क्वेश्चन का आंसर क्या होगा, जल्दी बताओ. So your decision making tendency decides here. NEET examination में your decision making tendency decides everything. Supriya Bharti, you want to say A? So A is benzene. Now you can see this is your structure CH3 and this is your structure CH and CH3 and CH3 like this, and you can say CH2 and CH3 and like this, right? Now this is going to be 3 alpha hydrogens, 1 alpha hydrogen, and you are going to see 2 alpha hydrogen का हिसाब से हाइपर कॉन्जुगेशन चल रहा है, हाइपर कॉन्जुगेशन चल रहा है, हाइपर कॉन्जुगेशन चल रहा है. सो यहाँ पर हाइपर कॉन्जुगेशन है, ज़्यादा हाइपर कॉन्जुगेशन है, ज़्यादा रिएक्टिव होगा. माय आंसर फॉर दिस क्वेश्चन इज गोइंग टू बी बी. ट्रैप. Anushka Rai, trap. Supriya Bharti, you understand your mistake. So in this YouTube channel, we are conducting the sessions to boost up the confidence with the students' mindset, and also we are conducting these sessions to get this opportunity to get the best for every student. Tiwari, okay, Sheikh Tahira and Anushka Rai and Bharti, Supriya. Come on, next question. Next question. Yes, answer is going to be B. Now here it is going to be the order of decreasing reactivity towards electrophilic reagent for the following. So it is going to be benzene. This is your benzene. And it is toluene. So this is going to be toluene. And it is a chlorobenzene. And it is D, anisole. What is anisole? Now this is anisole. Yes, 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 yes. Now everybody look at this. What is the actual? This is having hyper conjugation. This is having a strong inductive effect, and this is having पॉजिटिव मीसोमेरिक इफेक्ट. सो पॉजिटिव मीसोमेरिक इफेक्ट की वजह से डी ज़्यादा से ज़्यादा रिएक्टिव होगा. देन बी हाइपर कॉन्जुगेशन का वजह से रिंग एक्टिवेशन है, एंड ए ओके. देन कम से कम सी होगा. अंडरस्टैंड क्लियर? कम से कम सी होगा. एवरीबॉडी यू अंडरस्टैंड क्लियर? लो वॉइस. इज माई वॉइस इज क्लियर बच्चों? Is my voice is clear? Yes. Now let's see. One more question. Yes, of course it is DBAC. DBAC, my answer C. Clear? We are solving it. Wonderful, my dear children. Now let's talk about among the order of decreasing reactivity towards electrophilic substitution reaction. Now it is a CH3. Let us say this is a CH3. Okay, let's say CH3 and OCH3. So it is not clear. I want to write CF3. Okay. Now you all tell me what is the actual order for this. You all tell me. Low voice. Okay, dear children, you can say this CH3 has positive inductive effect. This has a positive inductive effect and a positive hyperconjugation and no effect at all. And it is going to be positive mesomeric effect and it is going to be strong, super strong negative inductive effect. I would say, and 3 is going to be more reactive, and it is going to be 1 is going to be more reactive, then 2 is going to be more reactive than 4. Actually, this 4 usually do not participate, Anushka, usually do not participate any kind of electrophilic reaction such as super deactivating group. Super deactivating group. Okay, because of the strong minus I effect. Understand? Now the answer is going to be B, Anushka, you said it is correct. And one more, number of possible dichloronitrobenzene. Dichloronitrobenzene, कितना dichloronitrobenzene आप मिल सकते हैं? Answer, possible dichloronitrobenzenes कितना आ सकते हैं? So dichloronitrobenzene, this is your nitrobenzene ना. I can make it chlorine here, I can make it chlorine here, I can make it chlorine here, I can make it chlorine here. You see how possibly you write. I can make it chlorine here, I can make it chlorine here. Arre, और कितना आ रहा है? I can make it chlorine here, and I can make it chlorine here with respect to nitro. Right? I can make it nitro here, here also one more, and also you can say you can get it in these two possible ways like this. Yes, total 6 I am going to get it. Clear? Supriya Bharti got C, total 6. Wonderful, wonderful, it is going to be 6. Clear? Right, next one, we'll do one more. Yes, I get it 6 again. So these are all the various possibilities. One thing I want to give you, my dear students, whenever you give the name for the given possible isomers, the name, if you have a different name, that is a possible structure. If the same structure you want to claim it, you should get the same name, so which is not actually the correct structure. So that is the way you can identify whether you did it correct or not. And the major product formed in the monobromination of phenyl benzoate. Answer? So major product formed on monobromination of phenyl benzoate. So phenyl benzoate, this is your phenyl benzoate. Okay, now this phenyl benzoate is checked with where this is going on, so this is ring activated. So we have to activate that ring. Okay, now this is going to be option D is the correct answer. So this carbonyl carbon containing phenyl benzene is not actually brominated. Now your answer is going to be D in this case. Okay, you all understood this? Clear? Now, we'll do one more. Yes, the major product of the following reaction is the major product. So, you want me to rewrite this? If you are okay, I can rewrite this because the structure may not be that clearly visible. OMe, when it is treated with CH3 twice, CH3 twice and CH2Br. What could be the answer for this? Anushka Rai. In the presence of AlCl3 and you heated the product. So, I just want to rewrite this structure. Let me give you the preparation of this. So, CH3, CH and CH3 and CH2. Now, it is going to be bromine in the presence of AlCl3. So, you are going to get a bond is broken here, CH3, CH and CH3 and CH2 plus banega. So, this is a primary carbocation. This primary carbocation is less stable. So, it is going to rearrange itself. So, that the hydrogen present here is going to migrate over here. So, that you are going to get CH3 C plus a tertiary carbocation Banchuka. So, this is going to be tertiary carbocation. This tertiary carbocation is going to react with, so what is this anisole? This anisole is going to be CH3 पॉजिटिव मेसोमेरिक इफेक्ट का हिसाब से ये रिंग एक्टिवेटर है, so that it is going to attack this and the end product of this is going to be here OCH3 CH3 and tertiary para tertiary butyl anisole is going to be the product. Okay, and para, yeah, my answer is going to be D. Answer is going to be D. समझ में आ रही क्या अनुष्का रॉय? Okay, next question. Just give me the answer. So here the nitration of benzene with a mixture of concentrated HNO3 and concentrated H2, so the active species present in it, that is going to be active species present in it is NO2 plus, that is going to be NO2 plus. Okay, I just want to give you the overall active species with that, with the 5 golden reactions of benzene. I'll come back to that. Okay, so many reactions are there, wonderful. Yes, electrophilic aromatic substitution reactions. Okay, in this you can say yes, it is going to be electrophilic aromatic substitution reaction, where you can have the benzene is reacted with the chlorine in the presence of FeCl3, you are going to get chlorobenzene, and this is what is called as hallucination. In this hallucination, the active species is going to be the electrophile. The electrophile is going to be Cl plus is the electrophile in this reaction. Cl plus is the electrophile in this reaction. Anushka Rai, fine. When benzene is treated with HNO3 and H2SO4, you are going to get nitrobenzene. In this nitration, you are going to get NO2 plus is the active ingredient in that. Okay, and benzene is treated with sulfur trioxide and H2SO4. You are going to get benzene sulfonic acid. This reaction is called sulfonation, and this is of course reversible in nature. Therefore, we can write this reaction in this way. In this, SO3 is the active ingredient. Electrophile is going to be SO3. And you can see RCl, AlCl3 react with benzene. You are going to get alkyl benzene. This is what is called as Friedel-Crafts alkylation. You are going to get alkyl carbocation is the reaction intermediate, where it is going to be a rearrangement is possible. Rearrangement is possible. Okay, Anushka Roy, let's follow the chemistry class here. Let's follow the chemistry class here. When RCOCl is there, it is called Friedel-Crafts acylation, and you are going to see the formation of RC double bond O plus is there. Okay, this is what is called as Friedel-Crafts acylation. Acylinium ion is the intermediate, which is resonance stabilized. Can you tell me the basic difference between Friedel-Crafts alkylation and Friedel-Crafts acylation? In Friedel-Crafts alkylation, there is a polyalkylation may takes place, whereas a Friedel-Crafts acylation, polyacylation do not takes place. Understand? And this is a very, very important slide. Everybody take a snapshot of this. Snapshot of this. Click it. You'll understand. Click it once. 3, 2, 1. Click. Now, let's talk about, yeah, we discussed about this. Some questions we'll discuss. Some questions we'll discuss. Now, quick. So, sulfonation differs from most of the electrophilic aromatic substitution reaction, which the fact that reaction is. What makes the difference between the sulfonation and other reactions? Anushka, quick. So, it is a reversible reaction. It is just like all electrophilic substitution reaction, but it is a bit reversible reaction. Okay. So, answer for this question is going to be A. That's good, nice. And let's see, cumene on treatment with KMnO4 gives. What is the meaning of cumene? CH this is what is called isopropyl benzene, and this cumene is treated with KMnO4. Okay, what happens, you know, this is called benzylic hydrogen. It is more prone for oxidation. मान के चलो, it is more prone for oxidation. जब ये KMnO4 से ऑक्सीडाइज कर रहे हैं ना, ये बॉन्ड काटने के बाद any alkylated benzene on treatment with KMnO4, you are going to get benzoic acid as a product. Condition क्या है? ये कंडीशन है, जब तक एक बेंजाइलिक हाइड्रोजन है और बेंजाइलिक कार्बन एक पाई बॉन्ड होना है. So these are the conditions where I am going to get benzoic acid. B is the correct answer for this question. B is the correct answer for this question. ठीक है? Answer for this question is going to be B. That's good. Fantastic. Okay. Now one more question. So benzene react with CH3COCl in presence of anhydrous AlCl3. Quick! Friedel-Crafts acylation. It is going to be benzene treated with CH3COCl AlCl3. It is going to be COCH3 Friedel-Crafts acylation. This is your product. So the answer is going to be acylation, acetophenone. This is called acetophenone. Got it? Now, when the toluene is reacted with Br2FeBr3, the major product is, you only tell me, the major product is going to be. Quick. G. How do you get ortho at 50%? थोड़ा सा repulsion का हिसाब से ये 50% नहीं होगा. It is going to be majorly this. Okay, the answer is going to be C. The answer is going to be C. ठीक है? C was the previous answer. That's good. That's good. So, the nitration mixture, benzene treated with nitration mixture to get nitrobenzene. So, what kind of reaction is this? What kind of reaction is this? What kind of reaction is this? It is going to be electrophilic aromatic substitution. Substitution, electrophilic aromatic. Yes, that's good, Anushka. You did it well. And what is this? Name the intermediate produced during the reaction. Name the intermediate produced during this reaction. Sigma complex, Whelan complex, Whelan intermediate. It is going to be sigma complex and Whelan intermediate. The answer is going to be sigma complex. That is not uranium ion. Okay, that's good. Now, most reactive towards nitration, substitution, electrophilic aromatic. Who is going to be the most reactive? Here the electron pair of there. So, this electron pair and coming and joining here, it is going to be positive mesomeric effect का हिसाब से ये ज़्यादा से ज़्यादा reactive होगा. Answer is going to be A for this question. So, my dear children, today we discussed about what is benzene, aromaticity, non-aromatic, anti-aromatic, and preparation of benzene, properties of benzene, electrophilic aromatic substitution in that 5 golden reactions, hallucination, nitration, sulfonation, reversibility of sulfonation, and Friedel-Crafts alkylation, Friedel-Crafts acylation, and direct to influence of benzene ring. So, based on this, you are going to get a very good number of questions, and some questions are also being discussed. So, my dear children, let us discuss some more topics in future classes also. Get ready for that. We will be discussing with a new series about this. The grant test series discussion is also there to support you all guys, and we'll discuss these things. And stay tuned, and please like our session and share with your friends, and subscribe to Infinity Learn NEET YouTube channel so that you will be getting updates on when the classes and how the classes are going to happen. Okay, thank you very much. See you, and signing off, Suresh, Faculty of Chemistry from Infinity Learn. Bye bye, see you.